Welcome to Pomodoro Joe for Wednesday, February 15th, 2023. Today we'll be doing LeetCode problem 989, add to array form of integer. This is an easy problem. And the problem statement says, the array form of an integer num is an array representing its digits from left to right. For example, the num 1321, the array form is 1, 3, 2, 1. Given num, the array form of an integer and an integer k, return the array form of the integer num plus k. Okay, this is pretty straightforward actually. We have some array form of an integer, which is just each individual digit, and we have some k, which looks like it is a straight up integer. Okay, so how do we approach this problem? Well, I think what I would want to do is break off each number one at a time from k, get the ones place number, grab that, add it to the right position in my num array, keep track of any carry, and move on. So essentially what I'll be doing is I'll be keeping an index into my num array, moving from right to left. Then I'll be keeping a remaining value of k, just grabbing the ones position every time, and then reducing my k by a factor of 10 every time through the loop. So this will start as 34, and we'll just grab 4. Then k will become 3, and we'll grab 3, and then we're done. All right, let's put 25 minutes on the Pomodoro timer and get started. So we will have a result, and that will be an integer array, and we'll return that when we're done. What are the other pieces that we need for this problem? I think we'll need an index into our nums array. So we'll have an index, and we'll start that at the right end of our num array. So that'll be a length of num minus 1. What else do we need? We'll need to know how much of our k remains. So I'll say like k remaining. And we'll set it to k to start with. We'll also need to know if there's any carry bits. So let's carry, and we'll set it to 0. I think that might be all we actually need for our supporting variables. Now we'll just go through our num from right to left and our k, grabbing ones places off our k every time, and do our addition. How do we do this? We'll need a while loop. While what? Well, in this case, while we have a k that's greater than 0, so we have some number left in k, or while our index is greater than or equal to 0. So there might be some numbers left in num, or we might have a carry. So these are all things that can add to our result. We have some number left in k, we have some numbers left in our array of nums, or we have some carry left over. All right. Now, how do we reduce this problem? Well, we need to grab that ones position from our k. So we'll call that k1s. And that's going to be our remaining k. Oh, see, I've already made a mistake. We're not changing k itself, we're changing our k remaining. Let's do that. And this is called k remaining. All right, so the ones position can be grabbed out of our k remaining by doing a k remaining modulo 10. So essentially all that's saying is, what is the remainder when you divide by 10? So if you take any number and you divide it by 10, whatever's left over, that's your modulo 10. So for example, 11, the modulo would be 1, because 11 divided by 10 gives you 1 left over. It'll be 1 with 1 remainder. Okay, so we have our ones position. That's great. Now let's see. We'll do our nums1. Or I call it the nums value. How about that? So the num value. That's going to be our num at our index. So it's going to start at the far right, and we'll be moving to the left. What else do we have? We have our carry. Well, we're not going to do anything with our carry just yet. So now we have to do our calculation. We have to do the addition. So our new value will be our k at the ones position plus our num's value, whatever's in the matching position in our num, plus our carry in case we have any leftovers from the previous addition. All right, now that we have this, we have our new value. This value could be greater than 10. So we better check to see if our value is greater than 10. So if this new value is greater than or equal to 10, we need to cut this down into a single digit. So how do we do that? Well, it's very similar to how we did our K1s. We will say our value is equal to the value mod 10. So we just remove anything above the tenths place. You just grab the ones position. And we will have a carry. So this is where our carry gets set to 1. Because we're greater than 10, we'll carry this 1 over to the next position. All right, so we did our addition, we did our values. We need to now insert our value into our result. So the result, we will append this value. And now we need to do our sort of cleanup. We need to change both our k remaining and our index. Our carry is already taken care of, so let's see what's left to clean up here. So our k remaining will be k remaining divided by 10. And it's an integer divide by 10. So we're shifting our entire k to the right. We're dropping the ones place, shifting everything right. That's a divide by 10. And our index, we're moving from right to left, so we need to subtract 1. So I think this handles our basic addition. There's only one thing left to do. See if you can spot it. It has to do with how we're building up our result. So our result is being built from left to right. But we really want our result to go from right to left. So our entire result needs to be flipped. That's pretty easy to do in Python. You can just say result is equal to result. And then you slice it with a -1 step. This will reverse our result. Okay, I think that pretty much handles everything. What do you think? Should we give it a shot? All right, let's try it. Oh, and we have a problem. Ah, nuts. I missed this one crucial piece. If we have more places in our k than in our num, we can certainly end up running into negative indices. So we can handle this pretty easily, actually. Our num value is equal to the num at that index if that index is greater than or equal to 0. Otherwise, we can just set this to 0. It doesn't add anything into our equation. Okay, let's give that a shot. Oh, I already see what I did wrong here too. We need to reset our carry. If our carry ever gets set to 1, we're basically going to keep it at 1 always, which means that this will always be 1, which means that we will fail. So one crucial thing that I missed, we need to reset our carry here. Once we do our addition, then we can reset the carry to 0, possibly setting it back to 1 if our value is greater than 10. Okay, now we're done. I made so many mistakes today. Okay, looks like we're passing. Let's go ahead and submit this, see how well we do. Not too bad. We pass, beating 77% for runtime and 65% for memory. That's okay. I'll take it. It'd be nice if we could get that above 90% for runtime. Let's see if there's something we can do. So I will remove this comment because maybe I'm superstitious, but I think comments can actually cause parsing times to delay our runtime. This all looks pretty good. What else could we do to make this a little bit faster? Well, one thing I might try is moving this carry out to here. So let's see if we did this. Instead of saying or carry, we can say if carry at the end is equal to 1, then we will append 1 to our result. This might speed things up because we don't have to do an extra check every time through the loop. I'm not convinced it's going to make that much of a difference, but let's see. It still works. Let's see if we can make any gains in our runtime. A little bit. We're bumped up to 80%, but we dropped down to 36% for memory. It's a trade-off. What else could we possibly do on this one? Sometimes variable names can actually have an impact on our runtime. I know it sounds crazy, but let's try just renaming some of these variables. So result will become res. And index will become I. K remaining, we'll just call it R. All right, carry we'll call C. Okay, K1s we'll just call O. Num val we'll call N. And this val we'll just call V. Okay, this is pretty slim. We'll see if this makes any difference. This is just renaming variables. I don't expect any huge differences, but hey, it's worth a shot. 84%, it makes a tiny little bit of a difference. So it went from 80% to 84%. Honestly, this could just be variation in the back end running. It might have nothing to do with our renaming of variables. The only other thing I can think of here is perhaps moving some of these things around just to see if they can make a difference as to where you do these things. For example, this result, because we're using this R up here, and then we don't use it again, we could maybe put that here. Perhaps there's some caching involved, and maybe that will help. Let's see, what else can we do? This I we use here, and then we don't use again, so maybe we can move the I up here. This is complete speculation on my part that perhaps caching will help these things. Can't really move these around too much. All right, let's see if that helps at all. 88%, making modest improvements, going for that 90%. All right, one last thing, this V out here, let's declare our V outside of our loop so that maybe it won't have to be reallocated every time through the loop. Come on, 90% plus, let's do this. And it drops. I am running out of things I can do to make this leaner. Let's see if we can reduce any mods or divides. The only thing I can think left to do here is change our evaluation. I don't think this will make any difference. If anything, it might drop us back down. And we do it! Yes! Success! 95.33%. All right. Okay, just doing little tweaks got us there. Finally, we beat 95.3% of other algorithms for runtime, and we beat 36% for memory. Okay, here's our solution. That's the winner. All right, hope you had fun. Hope you enjoyed this. Hope you learned something. Hope you can go out and write better code than I did, that's for sure.